Welcome to The Explainer. Today, we are decoding something truly fascinating. We're looking at Scratch. Now, you might have heard of it as just a tool for kids, but we are going to approach it today as exactly what it is, a completely visual programming language. We're going to break down how it translates the normally intimidating world of coding syntax into a highly structured, super intuitive visual ecosystem.
Here is a quick roadmap for what we're covering today. First, the big picture. Then we'll check out the workspace. Jump into the grammar of shapes, explore the color-coded vocabulary, and finally wrap things up with the Creative Studio.
All right, Section 1, the big picture. Let's talk about what Scratch actually is and who it was built for.
So at its core, Scratch is a free, visual, block-based programming language. It was actually developed by the folks over at the MIT Media Lab, specifically for kids and beginners to learn programming concepts. And the real brilliance here? It totally throws out the need to type complex syntax. Instead, you're literally just dragging and connecting these bright, colorful blocks that act as commands to build interactive stories, games, animations, the whole shebang.
But that brings us to a really fascinating question. How in the world do you teach complex coding logic without typing a single line of text? Well, the secret sauce is in this no-syntax visual environment. The interface itself is basically your teacher and your guardrails. But to really grasp how that works, we need to look at where all this happens. Because just like a spoken language needs an environment to live in, a visual language needs a clearly defined workspace.
Which brings us to Section 2, the workspace. This is where the magic happens.
Okay, let's dive into this. Think of this as your personal command center. Spatially, the screen is divided to make everything super intuitive. Over on the far left, highlighted in that purple outline, you've got your code blocks. Those are your raw building materials. Right in the middle, in that green box, is your program area, which is where you actually construct your scripts. And on the right, outlined in yellow, is the stage. That's where you get to watch your sprite actors perform your code live right in real time.
Let's zoom in on those boundaries a bit. The stage, on the right, isn't just some random open canvas. It actually operates on a super strict coordinate system. Dead center is 0, 0. It stretches along an x-axis from -240 to +240 and a y-axis from -180 to +180. Meanwhile, that massive code area in the center is where the real action happens. You drag your blocks over from the left and literally snap them together like puzzle pieces to control what goes down on that coordinate grid on the right. But you might be wondering, how do you know which blocks actually snap together?
Let's look at Section 3, the grammar of shapes, or as I like to call it, physical syntax.
This is where that brilliant puzzle piece analogy really shines. In standard coding, if you type a command in the wrong spot, boom, syntax error, the program crashes. But Scratch solves this physically. Take a hat block, for example. It has a rounded top and a flat bottom. Because of that physical shape, it logically must go at the start of a script. Absolutely nothing can sit on top of it. Then you have stack blocks with notches on the top and bottom. Those are your middle action pieces. C blocks are literally shaped like the letter C so they can wrap around other blocks to make loops. And finally, cap blocks. Flat top, smooth, rounded bottom. They cap off the very end to stop a script. The physical shapes themselves literally teach you the grammar.
And it gets even cooler when we talk about data. See those pointed hexagonal blocks? Those are Booleans, and they report true or false conditions. And guess what? They only physically fit into hexagonal spaces on other blocks. Same goes for reporter blocks, which hold values like numbers or text. They've got rounded edges and only drop into rounded slots. So you literally cannot make a syntax error here. If it doesn't fit, it doesn't fit. It is absolutely foolproof. Okay, so we've got the grammar of the shapes down. Now we need the vocabulary. Because if the shapes dictate how blocks connect, the colors dictate what those blocks actually do.
Section 4, the color-coded vocabulary. Let's see what these blocks actually do.
And you know what the best part is? There are exactly 9 distinct block categories you need to master. Just 9. That keeps the whole learning curve totally finite, digestible, and super manageable for anyone just starting out.
Let's rapid fire through these buckets. Blue blocks are for motion, so moving and turning your sprites. Purple look blocks handle appearances and backdrops. Pink blocks are all about sound. Yellow event blocks are absolutely crucial. They're the triggers that kick off your scripts, like clicking the green flag. Orange control blocks handle your loops and pauses. Light blue sensing blocks are really cool. They detect things like collisions or mouse clicks. Green operator blocks take care of the math and logic. And finally, we've got variables and my blocks.
Actually, let's pause on those last two because they are super important. Variables basically act like labeled boxes for storing changing information. Think keeping a game score or a countdown timer. And that red My Blocks category, That lets you build custom, reusable functions. It just proves that even though Scratch is this fun, visual environment, it handles complex data storage and customized logic just as well as the heavy-duty typed languages out there. Which brings us to our final stop. This is where all that hardcore mathematical code logic crashes right into art and expression.
Section 5, the Creative Studio, where art meets logic. Now, what's really interesting about this slide is how Scratch handles its costume editor. You basically get a choice between two graphics modes. Bitmap mode is pixel-based. It's great if you want that painted art look, but if you scale it up, it gets fuzzy and blocky really fast. Vector mode, on the other hand, which is actually the default, is completely shape-based. It relies on mathematical shapes, meaning it doesn't matter how much you resize or zoom in on your character, those edges stay absolutely perfectly smooth.
And the Audio Studio follows a really similar, highly logical progression. The sound editor workflow is incredibly straightforward. First, you choose a sound from their massive built-in library, or just record your own. Then, looking right at the visual waveform display, you simply trim out the parts you don't want. Finally, you can go wild with engineered effects, speeding it up, giving it a cool robot modulation, adding an echo, or even running it in reverse.
So the crucial point is this. Whether you're creating a vector graphic, trimming down a sound wave, or snapping a blue motion block right under a yellow event hat, the whole thing relies on sequencing. Sequencing is just the fundamental programming concept of executing instructions in a strict top-to-bottom order. It is literally the heartbeat of this entire visual language.
So, what does this all mean? Well, it leaves us with a pretty mind-blowing thought to walk away with today. Scratch is always branded for beginners, right? But under the hood, it's an incredibly robust logic engine. If it can successfully teach the super complex computer science logic of loops, booleans, arrays, and sequencing just by using colorful puzzle pieces, what other wildly complex systems in our world could we decode visually? It's like a giant puzzle just waiting to be solved. Definitely something to think about as you continue learning. Thank you so much for joining me for this explainer, and keep exploring.